Howdy folks, this is a quick video just to get you able to wrap your mind around what I'm asking for the Group 3 NIEs. So you will notice that Group 3, we begin from this mixture of materials in the supernatant after the thioacetamide step. This is the stuff that you boiled on the hot plate or directly over a flame in order to eliminate the H2S. You have a selection of these ions, probably not every single one of them, and the new form that you're getting is going to include the first 6. We're going to leave out cadmium because it doesn't do a ton that's very interesting for us. So working our way through, what I want to point out is there are 4 reactions that are going to undergo multiple steps. First off, step 6. You'll notice that step 6 is composed of actually 3 reactions. The first thing you're going to do is add hydroxide, and yes, I know they're out of order here, but you're going to want to do these reactions in the order that they actually appear in the procedure. So it's hydroxide first, which you'll notice is going to be responsible for a lot of what you see. There's what happens to the iron, the nickel, the cadmium. Over here, the aluminum and the zinc are all reacting with that. It's manganese and chromium in particular that are going to be involved in the next 2 steps. After hydroxide, you're next adding bleach, NaClO. And then from there, you're adding ammonia. The first of those is going to be responsible for what happens to the chromate. The second is going to take the manganese to MnO2 from MnO4-. And we'll talk about those reactions in just a second, but for now I just want you to recognize that those 2 are going to need multiple steps in 6, and so I've made that very clear on the form, I hope. As for the other ones that are going to require multiple steps, step 13, you'll notice that you're adding acetic acid, then ammonia. And so notice what you've got here. Aluminum and zinc in particular, if they react with the acetic acid, that should take care of the hydroxide complex that's present here. But the addition of the ammonia is going to then crash this one back out, but complex this. It's a great way of separating those 2 metals. So I want you to show those in 2 steps. In particular, that last one you guys did on ionic reactions. That should seem very, very familiar. Working our way back through a few of these others, number 16 and number 17 are also both multi-step. Now that's not hiding from you here for step 17. You see barium chromate being dissolved in strong acid to become dichromate ion. Go look back at the Le Chatelier lab. You guys have actually done this one before. And then the last reaction is the one with peroxide to make CrO5. Similarly, over here in step 17, you're going to take zinc through 3 steps. First step is the addition of this ugly looking thing, which is potassium hexacyanoferrate 2. And so this is a complex ion sitting right here, and you'll notice it stays together and is the thing that precipitates out your zinc alongside some potassium, believe it or not. After this, you're going to do something very similar, but admittedly much messier looking than what you did in the with silver. Remember, with silver you had AgCl. You complexed it with ammonia, and then you hit it with acid to get rid of the ammonia and reprecipitate the solid. Well, the same thing's happening here. You're going to complex zinc with hydroxide. That's going to allow this to redissolve as the zinc basically turns back into that. And then you're going to hit that with HCl. You're going to turn all that hydroxide to H+, and you're going to remake the precipitate. So just keep an eye as you're going through this. If you really think about the way you did it for silver chloride and ammonia, it's the same idea here. It's just that the players are a little messier looking, okay? In particular, instead of a chloride ion, you have this ugly thing along with some K pluses. But that's the same idea. It's going to break apart when the zinc complexes and come back together when the zinc is uncomplexed. 2 other pieces of advice on this. I do want to point out step 11 where this takes place with the nickel. DMG has a very specific formula, and it's basically half of this. DMG's formula is HC4H7N2O2. And so you need 2 of the dimethylglyoxine molecules to make this product. You also have to figure out what happens to the H pluses that are involved, as well as the NH3s that break off from that. But make sure you get all of that there. I do not want to see DMG written on your NIEs. As for number 14, here, all I want you to show me is the dissolving process of the aluminum hydroxide getting dissolved by acetic acid. You don't need to write anything for the catechol violet. It's not really anything you can easily show as a chemical reaction. Also, briefly here, These two might have the look of a situation where you're adding multiple reagents in a certain order, but in both of these cases, the presence of the strong acid is just there to allow the redox to happen the way it needs to. So you don't need to write separate reactions for that. You just need to be ready to incorporate some H pluses into the equation on the reactant side. Now, we have a few redox reactions taking place in this, a few more of them than we had in the group 1 or 2 separations. So I do want to point them out. For each of these, step 6, step 8 right here, step 9, basically everything that happens to manganese, and the stuff you do here with chromium, these two are basically defined by the amount of redox chemistry they can do. For each of these situations, you do have one of the half cells basically provided for you. You can see that manganese 2 eventually is going to become MnO2. You can see that chromium is going to become chromate. You can also see over here that MnO2 becomes Mn2+, which then becomes permanganate, MnO4-. And over here you can see that dichromate becomes CrO5. Each of those have that half cell shown very, very clearly. On the other hand, the half cell involving whatever I'm adding, so the hypochlorite or the ammonia or the hydrogen peroxide or the bismuthate, that one is a little bit harder to spot without looking through the pages on manganese and chromium. And I would encourage you to do that. Look through those pages in your qual book as well. But I'm going to give you a couple of the half cells real quick here just so that you have a starting point, at the very least, what it is that hypochlorite or ammonia or H2O2 or bismuthate become. So in step 6b, you are adding bleach, which is ClO-. And I'll tell you right now that what it becomes in this reaction is Cl-. I know you might be tempted to go with Cl2, but that is not where you land. And one way you know that is that I don't make you do this step in the hood. If it was making chlorine gas, I absolutely would. Now, appended to this, for manganese and chromate are going to be two different half cells. So for chromium, you're going to be going from a complex ion that you form in the first step to chromate, the very final thing. Chromium doesn't do anything with the ammonia that you add later on, it just becomes this at the bleach step. By contrast, what manganese is going to do, after having become manganese hydroxide upon the addition of OH- in 6A, is it's going to become permanganate. And you know this in part because you've read a little bit in the procedure about how a purple foam might form at this point. Permanganate is a bright pinkish purple substance, particularly dark purple when it's concentrated. You'll see this later on in the conformation for manganese. Now, step 6c, as I said, doesn't affect chromate. That stays put. Step 6c is going to involve the addition of ammonia, which is going to become N2. As for the manganese, it's going to go in this case from MnO4- to MnO2, the final, very difficult to dissolve solid that you isolate from step 6. If you wind up with something that looks more or less like tar by the end of it, it probably means you have manganese in there. Moving on to the other redox reactions. In step 8, you're going to be encountering manganese going from MnO2 to Mn2+. This is where you redissolve it. To accomplish this, you're going to be adding H2O2, hydrogen peroxide, and it's going to it will become O2 gas. Step 9 involves Mn2+, becoming MnO4-, and in this case, you're going to be adding, to do that, sodium bismuthate, which is a solid in this case, and you're going to be turning that bismuth to Bi3+, and of course breaking off some sodiums. Again, balance the half cells, and you'll be good to go. Lastly, in number 16, again under very acidic conditions, you're going to be taking the dichromate ion that you made in 16A, so this is 16B, remember. You'll be taking that dichromate ion from that step and be turning it into CrO5. That will also involve H2O2 becoming oxygen gas. If you like all of this more in writing than you want it in an audio form, take a look at the assignment on the Canvas page, Group 3 NIEs, First Try.